Hello everyone, welcome in this lecture where we study the MCQs on the Fourier transform and inverse Fourier transform. Now see the table of Fourier transform and inverse transform. Here you can see while finding the Fourier transform for a given function defined in the interval minus infinity to plus infinity, the Fourier transform of a function f of x is denoted by the f of lambda, and it is defined by the integral from minus infinity to plus infinity f of x into e raised to minus I lambda x dx. And its inverse Fourier transform of this f of lambda gives us the value of f of x, and it is defined by f of x equal to 1 upon 2 pi integration from minus infinity plus infinity f of lambda e raised to I lambda x d lambda. Here you can observe that for Fourier transform we have a negative exponent, while for the inverse Fourier transform we have a positive exponent. For finding the Fourier transform for even function which is defined in the interval minus infinity to plus infinity, or for finding the Fourier cosine transform in the interval 0 to infinity, we have the same formula, that is fc of lambda, that is nothing but Fourier cosine transform of f of x, and it's given by the integration from 0 to infinity f of x cos lambda x dx. The inverse Fourier cosine transform of fc of lambda is defined by this integral, that is f of x is equal to 2 upon pi integration from 0 to infinity fc of lambda cos lambda x d lambda. Here we are integrating with respect to lambda so that we get a function of x at the end. Similarly, to find out the Fourier transform of odd function or in the interval minus infinity plus infinity, or to find out the Fourier sine transform in the interval 0 to infinity, we have the formula fs of lambda equal to integration from 0 to infinity f of x sine lambda x into dx. Now to find out the inverse Fourier sine transform, we have f of x is equal to 2 upon pi integration from 0 to infinity fs of lambda sine lambda x into d lambda. Here again you can see for finding the inverse Fourier transforms, we have to integrate with respect to lambda so that we can obtain the function f of x after it. Now look at the example. In the Fourier integral representation, 1 upon 2 pi integration from minus infinity plus infinity pi into 1 minus I lambda upon 1 plus lambda square e raised to I lambda x d lambda equal to, this function is given, that is f of x. We have to find f of lambda. As you know the definition of the Fourier transform, by definition we have f of x is equal to 1 upon 2 pi integration from minus infinity plus infinity f of lambda into e raised to I lambda x d lambda. When we compare the given expression with this definition of inverse Fourier transform, we can write the value of f of lambda as pi times 1 minus I lambda upon 1 plus lambda square. That is what the coefficient of e raised to I lambda x is representing the value of f of lambda. Therefore, in this example, f of lambda is equal to pi times 1 minus I lambda upon 1 plus lambda square. Therefore, correct option is D option. Now consider the next example. To find out a Fourier transform, f of lambda of a given f of x equal to 1 for mod x less than a and 0 for mod x greater than a. These four options are provided. Now again see, according to the definition of the Fourier transform, we have f of lambda equal to integration from minus infinity plus infinity f of x into e raised to minus I lambda x into dx. Okay, now when we are having the range mod of x is less than a, mod x is less than a, it representing the domain where x lies between minus a to plus a. Therefore, we just split up this integration in the three parts, minus infinity to minus a to a, and then from a to infinity. And in this middle interval, we have the value of function f of x is equal to 1, and for the remaining part, it is equal to 0. Therefore, just placing the value of f of x equal to 1, we have this kind of integration from minus a to plus a, e raised to minus I lambda x into dx. Now here integration of this e raised to minus I lambda x is what? E raised to minus I lambda x upon minus I lambda. Just put the limits from minus a to plus a. When we try to put the limit in place of x, for the upper limit, we have e raised to minus I lambda into a, minus sign, middle sign is negative, and then put upper limit x equals to minus a in this expression. Therefore, we get e raised to I lambda a. Now, here we can see the formula is what? E raised to I theta minus e raised to minus I theta upon 2a. It is giving what? It is equals to sine of theta. Therefore, to adjust this formula, we have just divide here by 2 and multiply by 2. And therefore, we have this expression 2 upon lambda. This negative sign is multiplied inside the bracket, and this expression is nothing but sine of lambda a. Therefore, when we compare it with given option, the correct option is A option. Now consider the next example. Here, the Fourier transform f of lambda of f of x equal to e raised to mod x is given by any one of these 4 options will be correct. And again, by using the definition of the Fourier transform, we have f of lambda equal to integration from minus infinity plus infinity f of x e raised to minus I lambda x into dx. Now, according to definition of the modulus function, we have modulus of x is equal to minus x for negative values of x, and it is equal to plus x for the positive values of x. Therefore, this range of integration can be split up into 2 integral parts, that is minus infinity to 0 and then from 0 to infinity. For minus infinity to 0, the value of e raised to mod x becomes e raised to minus x. Therefore, you can see here the f of x is e raised to minus mod x. Therefore, it becomes e raised to plus x. This kernel is as it is e raised to minus I lambda x into dx. Plus, for the positive part, this mod x become plus x, and therefore having negative sign out, we have e raised to minus x, e raised to minus I lambda x dx. Now, by taking x common from the power of these 2 exponent, as a basis same, we can take the addition of the powers, and by taking x common, we have this kind of arrangement in the both of the integrations. Now, integration of e raised to 1 minus I lambda x into x is what? E raised to 1 minus I lambda x upon 1 minus I lambda with the limits from minus infinity to plus infinity. Same thing we can do here. The integration of e raised to minus of 1 plus I lambda x is what? E raised to minus 1 plus I lambda x upon minus of 1 plus I lambda with the limits from 0 to infinity. Now you well know what is the value of e raised to 0? It is always equal to 1. Also, you know the e raised to minus infinity. The value of e raised to minus infinity is equal to always 0, right? Therefore, when we substitute the upper limit here, you get 1 upon 1 minus I lambda, and for the lower limit, we are getting simply 0. Same thing you can see here. When we put the upper limit, we get e raised to minus infinity, that is equal to 0. And when we try to put the lower limit, we have e raised to 0, that is equal to 1. And minus of minus become plus, therefore it is what? 1 upon 1 plus I lambda. Therefore, when we try to sum up these 2 terms, after taking the LCM, here you can see we have 1 plus I lambda plus 1 minus I lambda upon 1 minus I lambda into 1 plus I lambda. Now in the denominator, you can see here 1 minus I lambda into 1 plus I lambda becomes 1 minus I lambda its square, right? Actually, it is 1 square. And you know I square equal to how much? I square always equals to minus 1. Therefore, minus of minus 1 become plus, and therefore the denominator is what? 1 plus lambda square. Therefore, D option is correct option from the given options. Now look at the next example. If f of x equal to sine x for x lies between 0 to pi and it is 0 for x negative and x greater than pi, then here again we have to find out a Fourier transform of f of x. Options are provided. Again, by definition of the Fourier transform, we have this, and just observing the range of the given function, we just split the given function from minus infinity to 0, then 0 to pi, and then from pi to infinity. In the interval 0 to pi, the value of f of x is sine x. Therefore, we have this kind of arrangement: integration from 0 to pi sine x into e raised to minus I lambda x at dx. Now here we are using the formula that integration of e raised to ax into sine bx dx is equal to e raised to x upon a square plus b square a sine bx minus b cos bx. Here you can see value of a has to be put minus I lambda and b equals to 1. Using this substitution in this formula, we get this kind of arrangement. When I try to put the limits, for the upper limit, when we put x is equal to pi, you know sine pi equal to 0 and cos pi always equals to minus 1. Therefore, In the outer term, we have e raised to minus I lambda pi upon minus I lambda square is what? Minus lambda square, because what do you know? Minus 1 square is equal to plus 1. Also, minus 1 square equals, sorry, minus I square equal to what? I square equal to minus 1. Therefore, this term is negative 1, right? Therefore, here we are having minus lambda square plus 1. And in the limit, in the bracket, we have sin pi equal to 0, cos pi is equals to 1, and cos pi is equals to minus 1, minus of minus become plus 1. Therefore, we are getting for the upper limit, this term is okay. Now for the lower limit, when we put x equal to 0, e raised to 0 is 1. And same the denominator, we have minus lambda square plus 1. And as you know, cos 0 is 1. Therefore, we are having the term here minus 1. Sin 0 is equal to 0, right? And when we add these two terms together, we have e raised to minus I lambda pi upon 1 minus lambda square. Minus of minus become plus, and it is 1 upon 1 minus lambda square. Therefore, the final answer takes the form e raised to I lambda pi plus 1 upon 1 minus lambda square. Therefore, correct option is C option. Similarly, we can see the next example. The next example, to find out the Fourier transform f of lambda of f of x is given by x square for x positive, that is 0 for x negative. These options are provided. Now again, by using definition of Fourier transform in the interval 0 to infinity, f of x is x square. Therefore, here we have f of lambda equal to integration from 0 to infinity x square e raised to minus I lambda x into dx. Now integrating by using by parts rule, we can see here the first term here u is equal to x square, whose derivative eliminates earlier, and v is the function whose derivative is not vanishing. Therefore, here we have to keep first term constant, x square as it is. Integration of the second term is what? E raised to minus I lambda x upon minus I lambda, minus derivative of the first bracket, that is equal to 2x. Integration of the second bracket is what? E raised to minus I lambda x upon minus I lambda square. Again, the derivative of the first bracket is plus 2. And the integration of the second bracket is e raised to minus I lambda x upon minus I lambda bracket cube with the limits from 0 to infinity. When we try to put the limits, you know that e raised to minus infinity is equal to how much? E raised to minus infinity always equal to 0. Therefore, for the upper limit, we get 0 everywhere. And when we try to put the 0, when we put x equal to 0, due to this x square, this term tends to 0. This term also 0. Only one thing this is returning in the solution is what? When we put x equal to 0, e raised to 0 is 1. And therefore, for the lower limit, we are using negative sign. 2 times 1 upon minus I lambda its cube. Again, as you know, minus of I bracket cube. You know, I square equal to minus 1. And therefore, this minus I bracket cube becomes only I, right? Also, in order to fit the solution in the given option, we have 1 upon I is same as minus I. Therefore, this minus 1 upon I becomes positive I. Therefore, we have f of lambda equal to 2I upon lambda cube. And therefore, the correct option is C option. Now look at the next example. Here again, we have to find out a Fourier transform f of lambda of f of x, that is equal to 2 plus x for x positive and is 0 for x negative, and these options are provided. Again, by using the definition of the Fourier transform, we have f of lambda equal to integration from 0 to infinity 2 plus x e raised to minus I lambda x into dx. Again, integrating by using by parts rule, where u equal to 2 plus x and v equal to e raised to minus I lambda x dx. We have first term as it is. Then integration of the second term is what? E raised to minus I lambda x upon minus I lambda minus derivative of the first bracket, that is equal to plus 1, because derivative of 2 is 0 and derivative of 1 is equal to x equal to 1. The integration of the second bracket is what? E raised to minus I lambda x upon minus I lambda whole square. When you try to put the limits, what happens? Again, when you put upper limit, instead of x, we have e raised to minus infinity, that is equal to 0. And for the second term also, we are getting 0. Now try to put the lower limit, just put the minus sign in middle. E raised to 0 is 1 and x equal to 0. Therefore, the first term is becomes minus 2 upon minus I lambda. And in the second term again, when we try to put x equal to 0, here we are having plus sign. Lower limit minus, and this minus become plus, therefore it is 1 upon minus I lambda whole square. Therefore what we have, minus of minus become plus, and therefore we have 2 upon I lambda plus, minus of I whole square is equal to what? 1 square minus 1 square is 1, and I square becomes minus 1. Therefore the value of this term becomes minus of lambda square. Again, just rearranging as per requirement, you can see here 1 upon I becomes minus of I. Therefore the second term here is what? Minus 2I upon lambda. And therefore with this calculation, your correct option is A option. Now see the next example. The inverse Fourier transform f of x defined in the interval minus infinity to plus infinity of f of lambda equal to 1 minus I lambda upon 1 plus lambda square is. These options are provided. Again, now by using the definition of inverse Fourier transform, we have f of x equal to 1 upon 2 pi integration from minus into plus infinity f of lambda into e raised to I lambda x into d lambda. Here you know that the value of f of lambda equal to 1 minus I lambda upon 1 plus lambda square. Also you know that e raised to I theta equal to cos theta plus I sin theta, and using that identity you can write here cos of lambda x plus I sin lambda x into d lambda. Now let us multiply these brackets together, this term multiply together, and when we try to compare the real and imaginary part, you can see here the real part. When we multiply this real part with real part, we have cos of lambda x. When we multiply this imaginary part with imaginary part, and by using the term I square become minus 1, we have this term as plus lambda into sin lambda x. Real into real and imaginary into imaginary gives us real part. Now remaining part, when we multiply real part with imaginary part and imaginary part with real part, we get I common and this kind of arrangement. Therefore, when we compare this with given option, the correct option is a C option. Now, if the Fourier integral representation of f of x is 1 upon pi integration from 0 to infinity cos lambda x plus cos of lambda pi minus x upon 1 minus lambda square d lambda, this is your f of x, then the value of the integral from 0 to infinity cos lambda pi by 2 upon 1 minus lambda square d lambda is. These 4 options are provided. Now you can see when we put x is equal to pi by 2 in the left hand side of the given integral, what happens? When we put x equal to pi by 2, we have this term as 1 by pi integration from 0 to infinity cos of lambda pi by 2 plus cos lambda pi by 2 upon 1 minus lambda square d lambda. And for x is equal to pi by 2, when we observe the function f of x equal to pi by 2 lies in the interval 0 to pi, isn't it? Therefore, when we put x is equal to pi by 2 in this function, what we have? We get sine pi by 2. And you know that sine pi by 2 is equal to 1. Also, when we add these two terms together, these are identical terms, therefore it becomes 2 times cos of lambda pi upon 1 minus lambda square d lambda. Let us shift this term on the right side, and this 2 is also shifting toward the left side. It gives us pi by 2. Therefore, among the given options, D option is correct option, that is equals to pi by 2. Thank you for listening me.